Hi everyone, we're going to be working on the week 12 notes in this video today. So what I'm actually going to do is do it a little bit out of order. So please flip to page 113. Okay, the last page of the week 12 notes. We're going to start with the graph of an exponential function, and then I'm going to work you backwards to where we start, where the first page of the notes is. Okay. So remember what it means to be an exponential function. We talked about it in the last couple of videos. An exponential function just means that x is in the exponent, just like this example right here that we're about to graph. Now we haven't looked at what the graph of one of these looks like yet, so we're going to practice that first, and then I'm going to bring you into something called exponential regression. Okay, so to graph an exponential function really isn't much different than graphing a quadratic function. So you look at your equation. It says graph y equals 2 to the x and determine the asymptote, which we'll get to in a second, but right now let's just focus on how to graph this. What you're going to do is go to your calculator and hit the y equals button on the top left and type that in. Again, the same way you would graph a quadratic or a parabola, you're going to be plugging this in. So y equals 2 to the x, you're going to type 2 and then hit that caret and then hit the x button. So y equals 2 caret x is really what you're typing in. Now I want you to hit graph on the top right to see what it's supposed to look like. You should be seeing something that goes woo and just kind of zooms up. Okay, it's growing exponentially, which you may have heard before. It's definitely increasing like crazy. But to actually plot this, what you're going to need to press is second on the top left of your calculator and then press that graph button on the top right to get your list of points that you're going to be plotting on this grid. Now the problem with exponential functions is you get some really big numbers really fast, and you also will start with some really tiny numbers if you keep going in certain directions. Okay, so remember, you can navigate your table by pressing the up and down arrows. You just want to make sure you're finding the points on this table that are plottable. Okay, so what I mean by that is if you have the number 1024 or something like that, it's not going to fit on this grid. This grid only goes out to 10 in each direction. So what I'm going to start at with you guys is an x value of -3. So if you're not there already, find that x value of -3. The y value that goes along with it is 0.125. If you go any further than that to -4, -5, -6, the decimals get way too small to plot within the area that you have on the grid. So that's about as small as you can do. You could even start at -2 if you wanted to try plotting -4. There's nothing wrong with that. You just want to make this easy for yourself. So -2, if you start there, is 0.25, or technically 0.25. That's easy to plot for sure. It's a quarter, so it's about a quarter through one of the boxes. Okay, my next point on the table is -1.5. So that one's a little bit easier to plot as well. It's just half. And then from there you get some nicer numbers. So 0 has a y value of 1. An x value of 1 is at a y value of 2. 2, 4. Next is 3, 8. And then the point after 3, 8, you should be seeing 4, 16. We can't plot 4, 16 because, again, our grid only goes out to 10 in each direction. So that tells me I'm not going to be able to plot anymore. If you keep going further down than that, your numbers are all of a sudden going to be in the hundreds, 200s, 500s, really fast. And those definitely can't be plotted. All right, so on my grid, I'm just going to plot all of those points from my table. So the first point being -3.125. Think about decimals as though they're money. That's about 12 or 13 cents. So when I go to where x is -3, that's right here. Okay, just so you have a reference point of where I am. And I have to go up to 12 cents when this is $1. So 12 cents is like way down here. And just do your best to graph it as best as you can. Okay. Next one is -2 is an x value, so I go to the left 2, and I have to go up a quarter of this box, so a little bit higher than the last one. Just go up about a quarter of the box for about 25 cents. -1 is 50 cents, so I have to go up about halfway for 0.5. Right there, that one's a little bit easier, and then from here it just gets easier and easier. So my next point, 0, 1, is where x is 0, so I stay at the origin. I don't go left or right at all, and I go up to 1. My next point, 1, 2, means I go to where x is 1, match that up with where y is 2. Then 2, 4, I go right 2, up 4. And 3, 8, I go right 3, up 8. Now if you hit that graph button again on your calculator, just to make sure it looks like this, you should be matching up. If you've got something crazy that doesn't look like what the graph on your calculator looked like, you definitely plotted something wrong. Okay, now when you connect these, you want to make sure that your bottom like slide towards the end doesn't cross the x-axis. If you were to keep plotting these points, they would just keep going on and on. If you go up in your table and investigate what the y values look like, you'll notice they never become negative. So take a second, go back to your calculator and just scroll up at least 10 numbers and keep an eye on your y values. They get really, really, really small, but they never hit 0 and they never get negative. What that tells you is that your graph is just going to keep sliding down like this and get closer and closer to that x-axis, but it's never going to touch it. Okay, so that's how you want to draw that side of your graph. The right side's much easier. You just connect your points, and then it goes up. All right, so once you have your graph plotted and you understand this concept over here, when you scrolled up on your table, just a refresher again, your y values never hit negative, or never hit a negative number and never actually become 0. It just gets smaller and smaller and smaller forever. 0.000000001. It'll keep getting smaller and smaller and smaller and smaller, but never actually hit that x-axis. Okay, so part B is going to kind of relay that information. So part B says describe what it means to be an asymptote and then state what this asymptote of the above graph is. So first, let's define what it means to be an asymptote. Probably the weirdest spelling math word. Asymptote. So your asymptote is a line that the graph approaches but never touches. So again, an asymptote is a line that the graph approaches but never touches. Okay, so a line that the graph approaches but never touches. So think about where the asymptote would be on this graph. We kept talking about it, how these y values, no matter where you go in your table, they never, ever, ever hit a value of 0. They just keep getting really close to it, but never touch it. That means that this value, this y value of 0 right here, is your asymptote. Because your graph, I'm just going to highlight it, your graph comes down, 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 and just slides like along it, but never gets close enough to actually touch it. It's a weird concept. But your asymptote for this graph for y equals 2 to the x is the x-axis. You can also refer to the x-axis as the equation y equals 0. Both of these answers are definitely correct. Okay, your asymptote is the line y equals 0, which is also just your x-axis. They're both right. Okay, so now that we have a good idea of what an exponential function graph looks like, let's skip back up to page 111, the beginning of these notes. I thought this would be the easier way. There we go. So again, page 111, the beginning of the week 12 notes. So what we're going to do on this page and the next page is work on something called exponential regression. That word regression hopefully sounds familiar to you guys. Back in week 4 notes, we did something called linear regression. The regression method is going to be the same in your calculator. We're just doing it for a different type of function. So before we did it for linear, now we're going to be doing it for exponential functions. So what is regression? We talked about it before. I'm just going to refresh you on it now. Okay, so looking at this right here, linear scatter plot, I'm referring to this graph. A scatter plot means you don't have a perfect linear graph or a perfect line. You have a scatter plot of points basically kind of all over the place, but they represent some kind of pattern. So you'll notice that even though these points don't represent a perfect line, you can see that the relationship is linear. It has that linear pattern to it. And then this line that's drawn in here is referred to as your line of best fit. It's not a perfect line, but it's the line that best fits the data. So now we're going to look at that same thing over here, but for an exponential function. This curve looks a lot like the curve that we just graphed on the end of these notes, technically. But you'll notice that the points aren't a perfect curve. They don't represent a perfect exponential function. But you have this curve drawn in here. It's like the curve of best fit, where it tries to represent as many of the points as it can, as closely as it can represent. So what is regression? When we did a linear function, what you do is you're plugging in all the data for each and every one of these data points, and your calculator was calculating the slope and the y-intercept that would create that line of best fit. That's exactly what we're going to be doing for exponential scatter plot. You're going to be plugging in the x and y values into your lists from this entire graph, every single point. It'll be given to you in a table though. Okay, so every single point will be plugged into your L1 and your L2, and then your calculator is going to work some magic and it's going to calculate the equation for this curve of best fit. I just thumbs up to you guys. Wow. I'm sitting here by myself talking to an iPad and I did a thumbs up to you. I hope you accept my thumbs up. All right, so here's how you actually do it. Okay, here's the step-by-step in your calculator. Hopefully, when we read through this, it'll sound familiar to you. This will still be given to you on tests and quizzes. So given to you on tests and quizzes. But it's basically the how to do it in your calculator. So just a quick little side note for those of you that don't have a calculator and we're borrowing one from me, please use the simulator website that I posted in content on Blackboard. It's just a website that'll show you how to plug into L1 and L2 and do the exponential regression on there. If you have your calculator though, that's definitely the most ideal way to do it rather than switching between tabs and trying to work through some things. Okay? So the step-by-step in your calculator is kind of the same way that we did it before, where you would press stat, you press edit, you type your numbers, your x values into L1, you type your y values into L2, then you do this step 4. Step 4 is the only thing that's slightly different. You go to stat, you slide over to calc. This is the only difference between linear regression and exponential regression. We're not doing linear regression anymore, so you wouldn't choose linear regression. Once you get to that step, you're going to press exponential regression. Everything else is the exact same. Okay, so you can leave that page behind. I have the steps rewritten for you on this next page, so let's go ahead and flip to 112. Okay, and it says use the table below to answer the following questions. So part A says find an exponential equation. That right there tells me I need to use exponential regression. But I read further, it says that best represents the data above using exponential regression. So it tells you in the problem to use it, and it provides the step-by-step. So you'll always know when this applies. And then we'll round to the nearest hundredth once we get there. Okay, so the step-by-step in your calculator, try and follow it by what's written out for you, but I'm going to walk you through it verbally. So following that step-by-step, it says to first press stat. So I'm going to press stat. And then my calculator looks a little bit different than yours. It's the best I can get a video for you for, but you're then going to choose choice 1, which is edit. So again, yours looks a little different, but you press edit and you'll see something that looks like the top of my screen where you see an L1 and L2. Okay, you need to clear those out. So if you have numbers in them, which you probably do, you're going to use your arrows by highlighting over the L1 and the L2, and you're going to press clear, enter. Okay, then same thing, highlight over L2 and hit clear, enter. So you should have 2 completely cleared out lists. All right, now once you have that, we really are doing steps 2 and 3 together. We cleared out L1 and we cleared out L2. Step 2 says to then enter X values into L1, and step 3 says to then enter your Y values into L2. So if you look at the table provided to you in question 424, your X values are in the top row and your Y values are in the bottom row. So if I have to plug in my X values to L1, I'm going to start by pressing 2, enter, because that's my first X value. Then 4, enter, 8, enter, and so on. Then I'm going to do the same thing with L2 by typing in my Y value, so 44.7, enter, and so on. So if you are not completely plugged in, take a second and just pause it and finish plugging in. But once you come back and you have all of your numbers plugged in, I want to stress to you that your entire answer will be wrong if you don't plug in your numbers exactly how you see them. So even if you just accidentally miss a button, it'll mess up your whole answer. So before you move on to the next step, I recommend that you just check that you've plugged in your numbers correctly. I already double checked mine. They're all plugged in perfectly down to the decimal point. We are all good. So you just double check yours and then we'll move on to step 4. So step 4 says to press stat. So I'm going to press stat again. And remember, yours looks a little bit different than mine, but you're going to hit the right arrow like it says in step 4 to scroll over to calc on that top menu bar. You'll see I'm highlighted over calc now on the top of my bar. And then you're going to go down to choice 0. So scroll down until you see 0 exp reg. So you'll see mine right here, 0 exp reg. You select that. And then depending on your calculator, you just keep pressing enter until you get that final answer. So enter, 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 enter. Some of you only have to press it once. Some of you have to press it like 5 or 6 times. Whatever. You end up plugging it in, hit enter, and then this is the screen that should come up. If you don't have R values, don't worry about that. You're not going to need it for this lesson. But this is the information that you should get. And I'm going to write down what you are seeing at this point. Okay? Or what you should be seeing at this point, I should say. So this right here, y equals a times b to the x, yours looks different. It looks like, I believe, a times b caret x. Looks like a hot mess. This is the nicer way to write it and the way that we're actually going to be writing it. So this right here just means this. We don't ever write times with an asterisk. That's just how it gives it to you on your calculator. And we never actually write the caret. We just put x up in the exponent. So I used parentheses to show multiplication, and I moved that x up there already. Okay. If your A and B are not identical to mine, you typed something into your tables incorrectly. If that's happening to you, go back, check your tables, check your lists, make sure all of your numbers are correct. If you're still having an issue, send me an email or at least take a second to watch this YouTube video, okay, from this link. It'll just walk you through how to do it on the calculator if you're not following me verbally. Okay, so believe it or not, that's actually your answer. It's not compiled to the actual equation though. Remember the directions were find an exponential equation. I have to write out my final equation using this format that was given to me and plugging in the a and the b that are in that formula. So my y equals is going to come down. Before I plug in a and b, I'm going to round to what it asked me to round to, which is the nearest hundredth. So this first one, hundredth, is 2 places after the decimal point. So really I need to stop right here for a. But you look at the number after it, see if it bumps that up, 5 or above, give it a shove. So that one does round up to 47.97. This next one, here's my decimal point, 2 places after, is going to end me here. But again, I look at that number after it, 4 does not bump that up, so this one's going to stay 0.94. So now that I have my rounded versions of a and b, I'm going to plug them into my formula where it tells me to. So again, I'm referring to this up here. So I have my y equals already. I'm going to plug in a next. So 47.97 times b, so times 0.94, and that's raised to the x. This is your final answer. Okay, now having that correct in part A is so important because we're now going to use it for parts B and C. So part B says use your equation from part A, so right away all I'm going to do is bring it down. Y equals 47.97 times 0.94 raised to the x. So use your equation from part A to predict the temperature of water after 48 hours have elapsed. So look at what it's giving me and what it's asking me to find. I have to predict the temperature of water. That's what we're trying to find here. Go back up to your table. It's asking me to find what letter if I'm trying to find the temperature. Did you answer me out loud? That would be weird. It's asking me to find y. Thumbs up. All right, I'm asked to find y because it's telling me to find the temperature. Y is temperature. Now look at what else it tells me. After 48 hours have elapsed, go back up. What letter represents hours? Look right here. Time in hours is x. So when it gives me 48 hours, it's ultimately telling me that x is 48. So it's like coded in there, but it's ultimately asking me to find y when x is 48. So that's what I'm going to do. I'm going to leave y alone. Oh my gosh. Leave y alone. Bring down the 47.97 times 0.94, and then plug in 48 for x. So what you're going to do at this point is plug this part right here into your calculator with the parentheses, with the exponent, all the decimals, exactly how you see it. When you do, and you should practice plugging it in, double check that you get the decimal that I am writing. And you're plugging it in exactly how you see it, parentheses, exponents, everything exactly where it is. Okay. Hopefully we got that decimal. If not, again, please reach out to me in some way. It asks us to round to the nearest tenth. Tenth is only 1 place after the decimal point. So here's my decimal point. Here's my tenths place, but I have to look at that digit after it. It bumps it up. So this is going to be 2.5 feet. Or not, yeah, no, not feet. Sorry, my answer key says feet. It is temperature, so this is degrees Celsius. All right, part C. Again, use the equation from part A. So my first step here is to just bring down that equation. Y is equal to 47.97 times 0.94 to the x. So again, use the equation from part A to estimate the time x. So for this one, it's asking me to find x in hours that the temperature of the water was at exactly 30 degrees Celsius. So this right here, the temperature of the water is at 30 degrees. Remember what variable temperature is. If you don't, go back up. Here's temperature right here. Temperature is Y. So even though it doesn't come out directly to tell you, when it says the temperature is 30, it's telling you Y is 30. Just like in the last problem when it said 48 hours, it wasn't telling you X is 48, but it told you hours is 48, so X is 48. So for this one, Y is 30, and I have to find X. So now when I plug in, I'm not plugging into my exponent, I'm plugging in right here for Y. So this is going to end up being 30 equals, everything else comes down, 47.97 times 0.94, and I'm trying to solve for X. Now because I'm solving for X, look at where X is. X is up in the exponent, which tells me that I need to use logs to solve this. If I need to use logs, remember the setup for logs. Take a second to think about it on your own. This is not in the correct setup. Before you can take the log of both sides, you need the number that's being raised to the X to be by itself, and it's not right now. I have to get rid of that 47.97. Now the 47.97 is being multiplied to the 0.94 that needs to be alone. So to get rid of it, I'm going to divide both sides by 47.97. So that those cancel out, and I'm left with 0.94 to the X on the right side. The left side, unfortunately, is not going to be a nice number. You're going to do 30 divided by 47.97 in your calculator, and you're going to get a long decimal. Think to yourself, can you round it right now? You better have said no. You are never allowed to round until your last step. So unfortunately, you're going to have to write out that whole decimal. Now, even though this is ugly, it's in the right setup. I have what's being raised to the X by itself, so I'm good to go and start using logs. So to use logs, you write the word log in front of both sides. Okay, what I'm going to do right now, and it may or may not help you, you might like it, you might hate it, show you a little shortcut. Okay, remember, it's not really a shortcut, it's just to skip a step. The whole point in writing the word log is to take that X and bring it down in front. So rather than rewriting it all in this next step, I'm just going to bring it down right here and get rid of it up here. Okay, that's what I normally would have written in my whole next step right here, but since I have such a long, ugly decimal, and I know you guys don't want to write it again, you can just do it like that. The whole point in taking the log of both sides was to take that X that was just up here and bring it down in front of what it's attached to. I've done that, so I'm ready to move on. Okay. Now that I've brought that X down, the log has served its purpose. It brought X down and we're good to go. It's a solvable equation now. So to get X by itself, I have to get rid of what it's being multiplied by, which is the log of 0.94, and I undo that multiplication by dividing both sides by the log of 0.94. So this cancels out over here and I'm left with X by itself, which is awesome. You might be thinking right now, do I have to plug in that whole decimal in the calculator? Absolutely. You press log, it'll give you the open parentheses. You type in that whole thing. Don't forget to close your parentheses. Divided by the log of 0.94, close your parentheses. So take a second to plug that in. I'm just going to write down the answer that you hopefully get. Whoa. If you didn't get that, please go up and check that you plugged in the decimal correctly. This is what you should get. If you need more time to plug it in, just pause for a second. I'm going to go back up to my directions. It tells me to round to the nearest tenth. Tenth is one place after the decimal point. So right here, but you look at that digit after it, 5 or above, give it a shove. This one actually is going to bump up to 7.6, And that's going to be in hours because I just found X, and X was hours. So it takes 7.6 hours for the temperature to be at exactly 30 degrees. All right, and that is the end of the week 12 notes. Definitely practice another question like this from the week 12 homework assignment. Make sure you know how to plug it in your calculator. This is such a good question to know. Okay, you guys, this one is such a good question to know. Heck, this whole page is a good one to know. Let me just highlight the whole thing. This is not messy at all. Guys, this question's really important. That's why I'm being so obnoxious and highlighting the whole thing. Okay. And I did not give you a code word yet. My bad. So your code word for today's video is pizza. Okay, so your code word for today's video is pizza. So make sure you get that written down. Make sure you practice with exponential regression and doing a question just like parts B and C. Honestly, this whole page 112 is just super, super important. That's why I obnoxiously highlighted the whole thing. If you guys have questions for me, please reach out.